Hey guys, welcome to another tech tip from Calibrated Success. I have recently been doing some work with one of my clients, Fuel Injector Connection, and we were using the Fuel Injector test bench to run all of their injectors. And as you guys know, we've already been supplying the plug and play data. So you can see on screen here, this is our bench. It's a little different than the normal test tube bench that some of you guys have seen. This one actually gives us real complete characterization. So we test everything from where the injector just barely opens all the way up into the linear flow rate. And we do that at a bunch of different voltages. So we can get all that plug and play data for your ECU. Here's the really cool part. We've added the UTVs to that. So now, in addition to getting all these other OEM formats, we've added the UTVs. So without further ado, let's get into seeing how that data goes from our spreadsheet, which is a new interactive tool that you'll have to use with these UTVs, into your tuning software. So today's sample is going to be a BRP Maverick Turbo RR. And so we look that up and we see, well, what are we dealing with here? Because before we start tuning, we need to know a couple things. The big thing here is that we see down here, it is a 900cc triple cylinder engine. So we got to remember that, because the way that Bosch controller works inside the ECU, it normalizes everything down to a single cylinder basis. And we'll need to know how big each individual cylinder is to get the fuel injector data correct. So if I minimize that, here is the spreadsheet tool that you'll get from FIC. And you can see here's our data generator. And this is the one that we're using for the BRPs. And you'll see tabs along the bottom here. These are for the various injectors. So right now I'm on the 1200cc injector, part number 6040. This is the sample we're going to use. So we're going to put 1200cc injectors into a stock turbo RR. So we need to start with these four things over here on the left-hand side of the screen. So number one, we need to enter our engine size. So that engine, as we saw, is a 900, not 950. So we'll type 900 in, hit enter. And you see, as soon as you change that, some of these numbers over here on the right are changing as well. We know that is a triple cylinder engine. So we need to spread that 900 across 3 cylinders. Once again, the numbers change over here. No worries. We go to step 2, rail pressure. Stock is 450. But we have the ability to select that. And if you're running your own fuel system at a different pressure, like 3 bar or 4 bar, that can be selected. And as you select that, sometimes you'll see these numbers over here change as well. But we're going to stick with the stock 450 kPa system. The other thing is that we can choose between a returnless and a return fuel system. So factory is a returnless system. We need to make sure that is selected so we get the right numbers over on the right-hand side. And finally, ethanol content. Because these are not true flex fuel systems, we really basically tune it for one fuel chemistry. So pump gas is about 10%, and that's what most of our characterization work is done around. So we give you the number, we default to that 10%. But if you were blending your own fuel and you knew for sure you had 85% ethanol, you can type that in. You can see the numbers will change. If we had 0%, because we're putting rec fuel only in this thing, we're buying it specially with no ethanol content, type in your 0, we'll give you a slightly different number for that. But for right now, let's assume we're filling it up at the same gas station we filled our truck up at. And so 10% is the number. That gives us these numbers over here. And now we can transfer over to HPTuners. We've got our Turbo RR file opened. And under the engine fuel general tab, we see this whole column of injector stuff. So what we need to do is copy the stuff from our worksheet over into our tuning software. Pretty simple at this point. So we've got this new injector constant. I'm going to hit Control C to copy that. And I'm going to highlight the original value and hit Control V to paste that in. And we're going to do that on both variants here. So I'm going to hit Control V. And when I do that, you'll see that it rounds it off just a little bit. Don't worry about that. That's a number of decimal places away. That's just making it fit the binary data in the ECU. So that's our injector constant. Next up is our minimum pulse width. So I'm going to Control C to copy that. We're going to type that in over here, Control V. That's our new minimum. And then we get into the injector multiplier. So this is a pressure compensation curve. And you'll see that the factory has numbers in there almost identical to us. Really, if we keep the returnless system, these numbers basically aren't going to change a whole lot. But just for completeness, we've included it. And we just want to double check that we have the same breakpoints in our table. So 200, 300, 354, 455, and 550. Same breakpoints here. So we can just copy these by highlight, Control C, come over here, Control V, and paste those in, and they're done. Now, they didn't change a whole lot because we're basically using the same type of fuel system, but we give it to you anyway. Next up is your voltage offset. Now you'll see, once again, they have two variants, just like they did for the flow rate. So let's open that up. We're going to double check our axis breakpoints here. So 7, 8, 9, 10, 11, 13, 14, 16. And in the spreadsheet, I have 7, 8, 9, 10, 11, 13, 14, 16. So no reason to outsmart that. We're going to grab the row that matches the pressures that we're actually working at. So we're at 450 kPa. I'm going to Control C to copy that. I'm going to come back over to HPTuners, Control V to paste that in, and it's done. We'll repeat that process on the other variant just for completeness. So now both of those are updated. And the only thing it really leaves for us is this injector pulse multiplier, which they call pulse corrections over here, or injector pulse multiplier. You'll see there are 4 different variants of this. And from the factory on a Bosch controller, this table's a little funny. This table is kind of the fudge factor that the OEM uses to account for a number of different things. Some of them are injector related, and some of them are fuel rail related, or some of them might even be airflow related. It's kind of the catch-all fudge factor, but there is still a volumetric efficiency table in the ECU. So we are going to do our heavy lifting on our actual tuning over in the VE surface. We're going to put values in this table that fix the non-linearity of our fuel injector. And so that requires that we're going to grab the new values here. And in order to do that, I've got some changes here. You see, requires changes to the column axis breakpoints. So let me get that and scroll down a little bit so we can see where my breakpoints are. I added a little bit more resolution in some places here so that the areas that we use get more resolution. And so what we're going to do is go back to HPTuners. We're going to right click. We're going to go to that row axis and we're going to edit it. And so now we can see those breakpoints that were in the table. They're laid out this way. And we're just going to type in our new ones. So we start with 0.6, and then we go to 0.8, then we go to 1, then we go to 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.5, 3, 3.5, 4, 5, 6, 8, 10, and then we have 12, 13, 15, same as them. So now with those entered, we will have changed the vertical axis breakpoints, and you see they show up here in the software. Now we can just go ahead and grab all of our data from this table and get our non-linearity of the injector compensated correctly. So we're going to copy all of this by highlighting it, Control C. We're going to go back into HPTuners in that top corner, Control V, and paste it in. So now you see lots of different colors because we got rid of all the wonky up, down from the factory stuff. Their fudge factors have been erased. We start with a 1.0, a clean surface that matches what our fuel injector really does. And if there's any volumetric efficiency stuff that we have to move around, well, we'll handle that in the VE surface. So we now have a new injector pulse mult that fits our injectors in their nonlinearity. Now that's for variant 0. We replace the same things in variants 1, 2, and 3 here just for completeness. And after that, you're ready to get tuning.